section 5.1 video, part 2 of operations with polynomials. So earlier we learned just to understand the properties of exponents. We went through all that, and then we went through simplifying an expression. We also talked about classifying a polynomial, whether it was or not a polynomial, and also classifying its degree and putting them in order from least to greatest. So now we're just going to continue. We're going to actually continue simplifying polynomials. So let's look at this one. It's 4x squared minus 5x plus 6 minus 2x squared plus 3x plus 1. All right, so how do we simplify this expression? Because it didn't have an equal sign. I put an equal sign. But it doesn't have an equal sign, so it's just an expression. So we need to get rid of parentheses. Do I have anything on this side or this side, but to the left of the sign, the minus or plus? This happens to be a minus, which it would imply multiplication. I have nothing to distribute but a positive 1, so we know a positive 1 times anything is itself. So we can break the parentheses. Then here we have to distribute a what? An implied negative 1 to every term inside the parentheses. So this becomes minus 2x squared minus 3x minus 1. Now I'm going to regroup this. I'm putting an equal sign just to keep it a little neater. And I'm going to put like terms together. So that's the first thing I'm going to do. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just to make sure that I didn't miss something. All right. So now what do I need to do? I need to combine like terms. So this is a like term. These are like terms, and these are like terms. So 4x squared minus 2x squared is 2x squared minus 8x plus 5. And there's my answer. I can't go any further than that. That's as far as I can go. All right. So I think I have 4x squared minus 5x plus 6 minus 2x squared plus 3x. Oh, this was a minus 1, so this became a plus 1. All right. So plus 1, so this is actually plus 7. All right, let's try another one. Let's look at 6x squared minus 7x plus 8 plus negative 4x squared plus 9x minus 5. So the first thing we do is break the parentheses. 6x squared minus 7x plus 8. There's nothing but positive 1, so nothing changes. This is a positive times a negative, so this simply becomes minus 4x squared plus 9x minus 5. Now I'll combine like terms, so 6x squared. So I'm going to rearrange it so all my like terms are together. You have to be careful you don't miss a sign, you don't change a number, and you don't forget one or add an extra one. So this becomes 2x squared plus 2x plus 3. And there's your answer. There's nothing that you can go any further because you're just combining like terms. That's what simplifying is. So let's move on to another one. So let's do this one. 3x, 2x squared minus 4x plus 6. So we're going to use the distributive property here. And we're going to distribute 3x to every term. So this becomes 6x cubed, right, because x times x. And then we get minus 12x squared plus 18x. And there's your answer. All right, so let's look at example 5 on page 306 of your textbook. It's write a polynomial expression. It's a real-world example. So it says the U.S. Department of Transportation limits the time a truck driver can work between periods of rest to 10 hours. For the first part of his shift, Tom drives at a speed of 60 miles per hour. And for the second part of his shift, he drives at a speed of 70 miles per hour. Write a polynomial to represent the distance driven. So let's know what we know. So 60 miles per hour for some time and 70 miles per hour the rest of the time. So we're going to let x equal the number of hours that he drives at 60 miles per hour. Okay, so our expression is going to be 60 times x, right, plus 70 times 10 minus x. So now we just have to distribute. We get 60x plus 700 minus 70x, and we end up with 700 minus 10x, because these two are like terms and we combine them. So basically this is just a way to combine like terms and distribute and multiply. So let's look at number 6, multiplying polynomials. So I have n squared plus 4n minus 6 times n plus 2. So basically I'm going to take, and you can look at either way, and you have to use the distributive property. We can't FOIL because we don't have a binomial times, but we have a trinomial times binomial. So we're going to do n times this, n squared, this times this, and this. So let's start with n squared. So n squared times n plus n squared times 2, now we do 4, plus 4n times n plus 4n times 2. Then you have a minus 6, so minus 6 times n minus 6 times 2. So now I'm going to do, remember, product property of exponents, so it's n cubed, 2 plus 1, plus 2n squared, plus 4n squared, plus 8n, minus 6n, minus 12. Do I have any like terms? Those are like terms, those are like terms. We have n cubed plus 6n squared plus 2n minus 12. And there's your answer. I'm going to show you one other way before we end this video. So this has 3 terms. So I'm going to put the one with 3 terms on top, and I'm going to do n plus 2. All right? Just like you would if I had 134 times 21. We would start here and work our way that way and put a placeholder. We're going to do the opposite. We're going to start with n. So n times n squared is n cubed. N times this, the next term is 4n squared. N times that is minus 6n. Then I start with 2. 2 times n squared is 2n squared. So I'm going to align it up with my n squared. 2 times 4n is plus 8n, and then minus 12. This way, now I just go back and add like terms. They're already put together, they're in order, and it's nice and neat. So I have n cubed plus 6n squared plus 2n minus 12, which is what we got originally, and that is our answer. So you need to do problems number 2 and number 4, and we'll see you in class.